Hello and welcome again. Welcome to Safety Shorts series. So today's topic, as we were discussing the golden rules of safety, and today's golden rule is on electrical safety. Now, electrical safety is a practical application, and there has no limits. So the process of providing electricity to your home or any business, there are three parts. First is generation of electricity, where you produce the electricity. Then is the transmission, that is the movement of electricity from where it is generated to the point of distribution. And finally, the third stage, and that is the distribution stage, and where the delivery of electricity from transmission lines to your home or business is being done. Now, each stage involves distinctive production process, work activities, and hazards. Now, the hazards of electrical power generation process includes, I'm just trying to crux it out. So that includes explosions and burns resulting from unexpected equipment failure. Now, the major hazards present during the transmission process are, electrical failures to maintain proper approach distance that can result into serious injury or death. That is the during the transmission. And thirdly, the distribution substation reduces the transmitted electrical voltage. A distribution transformer further reduces the voltage. Hazards related to distribution work are accidental contact with equipment, shock, fire, etc. Now ये तो हमारा मोटा मोटा बात है. So आज ये हो गया इंग्लिश का पार्ट. अब हिंदी में बात करें. So हिंदी में अगर आपको इसको समझना है तो देखिए, ट्रांसमिशन के या किसी भी पावर इलेक्ट्रिकल सेफ्टी के बारे में जो हम लोग बात करेंगे, ये बहुत वास्ट टॉपिक है. तो मैं इसको क्रक्स में हम लोग जो चीज़ कवर कर सकते हैं उसके बारे में ही बात करते हैं. सो आज हम लोग बात करने वाले हैं. सबसे पहले तो आपको ये पता चलना चाहिए, इलेक्ट्रिकल जनरेशन के तीन हिस्से हैं, या इलेक्ट्रिकल सिस्टम के तीन हिस्से हैं: जनरेशन, ट्रांसमिशन और डिस्ट्रीब्यूशन. अब जनरेशन में क्या होता है? जनरेशन मतलब जहाँ पावर पैदा हो रही है. ट्रांसमिशन का मतलब क्या होता है कि इलेक्ट्रिसिटी का मूवमेंट जहाँ से जनरेट हुई है वहाँ से डिस्ट्रीब्यूशन जहाँ तक होना है वहाँ तक का जो हिस्सा है वो आता है ट्रांसमिशन में. और डिस्ट्रीब्यूशन, वो आप सब लोगों को पता ही है, जो इलेक्ट्रिसिटी डिस्ट्रीब्यूशन होता है जहाँ पे ट्रांसमिशन लाइन से आपके घरों तक या बिजनेस तक, फैक्ट्रीज में, प्लांट में, जहाँ से इलेक्ट्रिसिटी आती है. करेक्ट. अब हर तरह के सिस्टम में या हर तरह की प्रोविजन में अपने उसके खुद के कुछ हैजार्ड्स. सो व्हाट आर द हैजार्ड्स? सो इलेक्ट्रिकल हैजार्ड इन जनरेशन जो मेजर है वो है अनएक्सपेक्टेड इक्विपमेंट फेलियर्स. ये मेजर की बात हो रही है, मैं सब चीज़ों का कवर नहीं कर सकता हूँ. सो इसीलिए मेजर जो है वो होते हैं इक्विपमेंट फेलियर की वजह से. दूसरा हिस्सा जो ट्रांसमिशन में आता है वो आता है फेलियर टू मेंटेन अप्रोच डिस्टेंस. ट्रांसमिशन में आप समझ सकते हैं, भी ट्रांसमिट हो रहा है करंट इधर से उधर, तो जो डिस्टेंस है वो कम ज़्यादा हो जाता है, जिसकी वजह से सारी तकलीफें आती है, जिसके वजह से सीरियस इंजरी या डेथ होने की संभावनाएं होती है ना, इलेक्ट्रिक्यूशन. एंड देन डिस्ट्रीब्यूशन सबस्टेशन. अब डिस्ट्रीब्यूशन सबस्टेशन जो है ये बेसिकली, अब अलग अलग इक्विपमेंट है, छोटे छोटे इक्विपमेंट यहाँ पे होते हैं. तो ये जो इक्विपमेंट है ये क्या करते हैं? ये इक्विपमेंट जो हैं ये शॉक दे सकते हैं, या इनमें कभी फायर हो जाती है, कभी ओवरलोड हो गया, कभी ज़्यादा पावर कंज्यूम हो गया, कभी डिमांड ज़्यादा आ गई, तो ये सब चीज़ें यहाँ पे दिक्कत करती है. तो आइए देखते हैं कि इसमें what are the rules applicable. So the applicable rules in power generation, transmission and distribution. Let us first see that. What are the rules that are so following are the rules that are applicable. सबसे पहले, in India specifically, you have to refer to the CEA regulation 2010, and you have to look into chapter 8, that talks about safety requirements for overhead lines, underground cables and generating stations. एंड उसके बाद में आपको देखना पड़ेगा CA regulation. Again, then after that you have to refer CA regulation 2011, that talks about safety requirements for construction, operation and maintenance of electrical plants and electrical lines. Correct. So these are the two major standards that we have listed. Now let us understand some safety precautions. Now let us discuss the safety precautions needed to be taken up while working with high voltage and extra high voltage lines, that is HV and EHV equipments. Now before any person is allowed to carry out the work or repair or modification of any high or extra high voltage apparatus, a line clear to work should be obtained. All electrical apparatus should be considered as live unless it is positively known to be dead. Approved EHV tester should be used to verify that the circuit is not alive. No person should touch the insulation which covers or supports any conductor subject to high or extra high voltage unless the conductor is dead or earth. Now working space adjacent to the exposed live part should be used as passageways. Only authorized person to climb the structure or apparatus. Now working on dead lines and equipments. Now let us discuss the safety precautions to be taken up while working on dead line and equipments. The circuit or conductor to be worked on shall be made dead by switching off. A danger notice board with the word "Do not on" men on line should be fixed securely below the switch or link isolators. After switching off the supply, before touching the line, each conductor of the line shall be tested for pressure, voltage by discharge rod. Now ensure that there is no possibility of back feed due to some emergency electrical supply such as DG set, inverters or other energy source installed in the system. All details should be specified in the permit to work, and all conductors shall be earth. Poles on with work is actually to be carried out should also be earthen. Pole on which the work is to be carried out should also be earthen. Now let us understand some safe practices of transmission. So let us discuss the list of safety devices shall be used on overhead transmission lines. Now stipulates that every uninsulated line erected in a public place shall be provided with approved device rendering the line safe if it should break. Now guard wires must be provided above or below power lines when they cross telephone or telegraph lines. Lightning arresters are provided at the ends of HT and EHT transmission and distribution line and at every point of tapping. Fuse and isolating switch to isolate different parts of overhead system. A continuous earth wire running on top of the tower serves as a protection against lightning discharge. The guard lines must be galvanized and have a minimum breaking strength of 1400 pounds, which corresponds to SWG galvanized steel wire. Now, minimum vertical clearance between any conductor and guard wire should be 300 mm for low and medium voltage and 600 mm for 11 kV, 900 mm feet for 33 kV and 1.2 meters for 66 kV and 1.8 for 110 kV lines. Now choke coils are also sometimes used. Now let us discuss some safety in distribution for building services. Let us discuss some, something about building services. So distribution. There should be a proper coordination and collaboration between the architect, civil engineer, and electrical engineer and mechanical engineer. It should be effective from planning stage of installation. All door openings from substation, electrical rooms, etc. should be outwards, not inwards opening. It should always be outward opening. So if you're going to work inside, you should be easily able to come out. So it should be all should be working, opening outside. The provision for installation and removal of substation equipment should be provided from inside or outside the building without disturbing the associated major equipment in the substation. In place where flooding can occur and water level may go above 1 meter or 1000 mm, the base substation may be located on one level above the ground of utility building. In planning of electrical wiring installation, due consideration shall be made of all the prevailing condition. All HV cables shall be installed in accordance with good practice. Sufficient clearance as below shall be provided for the clearance should also be provided for isolating the switchboard to allow the access of service testing and maintenance. The main switch shall be easily accessible and situated as near as practicable to maintain or to terminate the service line. The location of main board should be such that it is easily accessible to firemen and other personnel to quickly disconnect the supply in case of emergency. Switchboard shall not be erected above gas stove or sink or within 2.5 meter of any washing utility in the washing room or laundries or bathrooms or lavatories or toilets or kitchens. Distribution board shall provide plenty of wiring space to allow working as well as to allow keeping the extra length of connecting cables likely to be required for maintenance. The distribution board shall be located as near as possible to the center of the load they are intended to control. Now coming to the general, now let us summarize this. So power is normally generated at a high voltage stepped up by transformer and then transmitted to the receiving station of the power supply companies, who in turn distribute the same to various customers after the voltage is suitably stepped down. There are three stages in electrical power supply, that is generation, transmission and distribution. CA Regulation 2010 Chapter 7 and CA Regulation 2011 are applicable rules available for power generation, transmission and distribution. CA Regulation 2011 belongs to safety requirements for construction, operation and maintenance of electrical plants and electrical lines. 400 kV and 220 kV voltage is a potential hazard. This can result in flashovers and fire, etc. Safety precautions needed to be taken up while working with HV and EHV, that is extra high voltage equipments, and on dead lines and equipments. CA regulation number 58 belongs to clearance above ground of the lowest conductor of overhead line, and CA regulation 60 belongs to clearance from the building of lines of voltage and service lines which is not exceeding 650 volts. Now, always try and list the precaution needed to be taken for inspection of equipment on or in the vicinity of live line. Safety devices should be used on overhead transmission lines. Earthing is making the connection to the general mass of earth. The supplier or the buyer are responsible for the safety of interface meters, and there should be a proper coordination and collaboration between the architect, civil engineer, electrical engineer and mechanical engineer while specifically designing the building services. So this concludes our general electrical safety shots. I hope I was able to contribute as much. Very much, friends. As you all know that safety shot, this is the series focusing on small safety videos. We'll keep posting more such videos, so keep liking and sharing, and do not forget to subscribe our channel. Thank you very much, friends.